I'm making this recording to show how you can actually use Sagemaker Studiolab, which is a free service that you can get. You don't need a credit card, just need an email address, and you can get both 4 hours of GPU server or 4 hours of CPU server on the Amazon cloud. And the service that you get is basically a Jupyter notebook. But what comes by default is actually not supporting some of the popular data science software like Scikit-learn, Pandas, and NumPy, etc., and even TensorFlow. So what I'm going to show you is how to actually install this after you sign in. So if you log into Studiolab, .sagemaker.aws. You can click on the sign in at the top. It will bring you to the next page, which basically gives you a sum of how many CPU and GPU runtime you have for the day. And every 24 hours, it will reset. So you can choose the type of compute. And before this stop runtime appears, is actually a start runtime button. Okay, so you choose whichever CPU type you want, and you can actually find out more information about the different runtime types that you want as well. I have actually chosen GPU and press the start button because I wanted to actually show you how you can use the GPU service, and it's 4 hours of GPU time that you have, and now the new limits are actually 8 hours of CPU time. So that's quite a generous offering that you have. So once you have started the runtime, the stop button will appear like you see here, and you need to click on Open Project to start the Jupyter Notebook or Jupyter Lab interface that you have. It's not Jupyter Notebook, but Jupyter Lab. So you click on Open Project, it will open up the Jupyter Lab interface. And by default, it will actually have a Get Started page like this. Okay. And you can see that it has some things. It's like a notebook, so you can just run normal Python code is fine. The default environment already has Python. You can see that you can actually choose other types and of kernels as well, but just stick to Python for now. Right. And you can see that the other interfaces are very similar. Now the thing is that you can't actually install run Scikit-learn and Pandas and NumPy data science libraries by default. So you actually need to install them. And I've shown you how to install in my other notebook which I've created. So how to create this notebook, you can always use the file and new, sorry, you have to go to this button here, okay, which creates a new launcher, and then you can actually create a new notebook, right? For example, how I created a Scikit, a Scikit, the IPYB is actually I open up the launcher by pressing the plus button as instructed, or you can actually press the plus button at the side here as well, and it will also create a new launcher. The launcher basically allows you to open several different types of files, including just the default file, right? And I'm going to basically open up the Python notebook, and I can save a new one. For example, here I can say just example of new file. Of course, you can switch between the code or markdown, and if it's a markdown, then it becomes a markdown like this. And you can, of course, rename the notebook to anything you want. New example, 2, for example, here. And it will be appearing on your list of folders. Now, this other button here is actually a list of kernels and terminals that are running, right? So currently, only these two are running. So if I open up the Scikit which I created earlier. You can see that actually to install the necessary packages, all you need to do is actually, let me make it a bit bigger, run this command, percent install or percent pip install. This is if you run it within the console itself, right? Actually, it's better not to run pandas install. And if you press this, it will actually just we run this cell, it will just install this, and is in the. You don't need to press yes and no because it will just run in the silent mode, right? I mean, it will run in a non-interactive mode, so you just run the thing to completion. This is a special percent inline command that they have for this. Now, this is one way, and then once you've installed Scikit-learn, which also install all dependencies for Scikit-learn, for example, NumPy would be installed together with Scikit-learn. You then probably want to install other libraries like Matplotlib, right? You can do a pip install Matplotlib, pip install Seaborn, and one other missing one, which is actually not here, would be you can also do a pip. Sorry. Pip install Pandas. Right? And this will install the packages that are not coming by not dependent, not going to be automatically installed with the Conda install Scikit-learn. Now, Conda is fully supported, so you can actually create additional environments. Like I want to create a Conda create environment Scikit-learn, and then I can activate those environments. But I am installing all this in the base environment just to keep things simple here. And once they have been installed, what would have actually originally caused an error, like in this case, this import pandas would then be able to work. So you can just run it and you will actually import it with no problem. Right, this is one way using the percent conda or percent pip install. The other way, which is more unusual for people who use the notebook, is to actually use the launcher and start a terminal. So this is like a normal Linux terminal. You open up a command prompt for you. I think I need to make it slightly smaller here. You can do ls command to show you where you are, right? And present working directory. And you can then, of course, do the install here, conda install Scikit-learn, for example, and it would just say everything is already installed in this case, so I can just safely run this. It will not do anything extra. I can see that it will just do the dependency check, etc. Right, and it's already done, right? So it has this. This is already installed because I did it earlier already. So once and then after that, you do your pip install Matplotlib, the pandas, and then it's like Seaborn here. Now this is the way you can do using the terminal. Now just remember that you need to restart the kernel, right? Once you've installed all this, because it would not be in the kernel that you've already started earlier. So for Scikit-learn, the other thing that you can install is actually TensorFlow with CUDA or without CUDA, like in this example here. So this is using the command on the terminal. So you can actually just run the same command here. I'm not going to run this again because it's likely to mess up my installation, but you can run this also, the Python. I don't need the exclamation mark if you run it from the main screen. So you can just run Python -m pip install CUDA and TensorFlow and CUDA. This is especially useful if you are running in a GPU environment so that the GPU can be used for your TensorFlow. But if you're running in the CPU environment, no worries. It will still run. It's just that you don't get the GPU support. Okay, it won't actually cause any failure in the package. Right. That's the main thing I wanted to go through with you in this video. Let me just close this without running that. If you open up the terminal again, you open a new terminal, so it won't be there anymore. Right. So just to show you that it works, you can run your import TensorFlow, and if you do a tf config list, yeah, there's some warnings. Tf config list GPU device, you can see that actually the GPU is enabled. The GPU they give you is fairly powerful, slightly better than what you can get on your own commercial grade GPU. And you can see more details from the main website's info FAQ. The version of TensorFlow is also definitely better than what you can run on Windows, which is just 2.10 native. So you get the latest TensorFlow with GPU support if you do this install. I just said, unlike Colab, this doesn't come pre-installed on Amazon. Okay, so you need to actually go through one more step to just install it. Once everything is installed, you do not need to repeatedly install it. The environment is safe for you in your user, your own internal user directories. So all you need to do is just to run your notebook after that, and it will automatically be there. But just a warning that if there's something that goes wrong, you need to remember to uninstall it, right? Because it doesn't actually automatically get uninstalled as well, right? So now my environment is set up. I can run my usual TensorFlow code, NumPy, and in my example here, I actually just create a fairly large array, and I convert it into a TensorFlow constant, and create another array B, NumPy array B, and I also create a constant from this, and then I just time, just using CPU alone versus time using the GPU computation. And you can see that actually, if the computation is pretty lightweight, you might not actually see a huge improvement in the time. But if the size grows larger, then you can see that actually the overhead in sending the job to the GPU would be less compared with this size. Okay, so just to show you, it's partly because yeah, you just have to be a bit careful that if you make it too large, it might take a very long time to run. So this is the 1 million record. Okay, done. Right. Then I have another 1 million record. And done. Now let's do the same thing again with the CPU. And now you can see that it's chugging along and taking a bit longer than just now, where it's only 1,000 by 1,000. Now it's 10,000 by 10,000, which is in the order of 10 to the, as you can see, it took 1.8 16.8 seconds now. And if I use the GPU, this is where you can see that it really has an advantage because time taken is much, much smaller. Okay. And just to check that I'm not cheating the shape, right? 10,000 by 10,000. You can see the time much better. And typically for GPU, there's a bit of initialization time. So the first time you run, it might take a bit longer. Like you notice that for the 1,000 by 1,000, it took longer than the CPU. But thereafter, once it gets warmed up, right, it will be faster. Right, that's all I have for you. Thanks. And I'm going to stop the recording.